Alrighty, trade classes. Ms. Sherman here. I'm going to run you through the cosecant and secant notes, and we'll get started here with a little bit of introduction and information, and then I'll do that first example for this video. I like to start the cosecant and secant notes every year with a discussion about this image. This is called a negative space image, where you can tell there's two different images kind of working here, and a lot of times people will look at this image and be asked, what do you see first? Some people might look at this image and see two faces, here and here, whereas some people might look at this image and see like a candlestick, or some people call this a chalice in between. Anyway, the point being, the reason this is called a negative space image is because the two images kind of work together, and one image exists in the space between the other images. That's going to be very similar to how secant and cosecant are going to work. Cosecant is going to exist in the space kind of around where the sine graph exists. Secant is going to exist in the space around where the cosine graph exists, in the negative space of each of these. I'm going to talk you through what these two graphs look like, kind of the parent functions here and some of the different important features, and then we'll get into that first example. I'm going to be using a lot of different pens today, different colors, to do a little bit of color coding, so I highly recommend if you've got different colors at your disposal to kind of pull those out and use them here. Okay, so first of all, I'm going to color code in here where the sine curve exists. And we've graphed sine before, so we should be able to pick this one out. So that's our sine curve existing in between, and if you want to kind of write this off to the side here, kind of label, that is sine there. All right, so then I'm going to mark in where our asymptotes for cosecant are going to exist. Those are going to occur anywhere where the sine curve crosses the sinusoidal axis. And if you think about the table, those are the values where sine comes out with a 0 output. If we took the reciprocal to get cosecant, that would be where you'd get 0 turning into its reciprocal, which would be undefined, because we'd flip it and then it would be undefined. So anyway, so these asymptotes are occurring everywhere you see these dashed lines. I'm putting those in purple. And those asymptotes will occur everywhere the sine graph crossed the sinusoidal axis. So at all the zeros, if you will, of the sine graph. Okay, so then, oh, I forgot one. There's one on the y-axis. Now I'm going to draw in the cosecant curves and just kind of highlight those. Cosecant, it's almost like I took this hill of the sine curve, flipped it up, and made it into kind of like a parabola up above here, and that curve is going to fit in between those two asymptotes. There's another curve here. There's a little part of a curve there. Another one here, here, and here. And I'm going to say, okay, this is cosecant, cosecant. So you can kind of see how this exists. It's kind of like the two faces up here. It kind of exists around the sine curve, whereas sine's in the middle, kind of like the candlestick or the chalice kind of item. Okay, let's do the same thing for cosine. So cosine exists here. And then if I put in my asymptotes, again, where the cosine curve crosses its sinusoidal axis, so at all of the zeros here. Okay. And then I'm going to highlight, kind of go over this. This is our cosecant curve, kind of imagining taking each of these hills and each of these valleys and kind of flipping them out to become these parabolas. All right, and this is secant in the red with cosine in the middle and the blue. And again, all your asymptotes, if you want to kind of put a little key to yourself, my asymptotes are all the purple. All right, so let's talk about some key info here. The period. The period is going to be 2 pi over b. That's because it's the same formula as sine and cosine. These graphs are going to be based on sine and cosine graphs, so a lot of things with sine and cosine are going to be very similar. We're going to list the domain the same way we've been listing it for tangent and cotangent. X cannot be equal to the asymptotes. So here I've got asymptotes at 0, pi, 2 pi. You will have to list all three of those. X cannot be 0, pi, 2 pi, because all three are in one cycle. This is one cycle, one full cycle of the cosecant graph. And the reason I need both of those is because if you think about a full cycle of sine, one full cycle of sine is going to match up with one full cycle of cosecant. So it's going to have one parabola opening up, if you will, and one opening down. Over here, cosine. So here's a cycle of cosine, same thing for a cycle of secant. It's going to go from 0 to 2 pi. So it's got half of this parabola, half of that one, and then a full one flipped down. All right, so back to our asymptotes. Asymptotes here at 0, pi, and 2 pi. Over here, looks like we have an asymptote at pi over 2 and 3 pi over 2. And again, that's how I'll write my domains. Those are my domains for the parent functions. I'll list that in that manner, and then for the asymptotes, I'd actually write with an equal sign there because I'm writing equations. Okay, range is kind of tricky. If you think back to how we did range at the very beginning of the year, remember this U symbol for union because we're going to have two linked set notation setups as we describe this range. We're describing the range of the cosecant graph and of the secant graph. So because of that, I need to describe just the space, just the vertical space that the red, function occupies. So that's why you're going to say it's going all the way down towards negative infinity, because these parabolas are pointing down. Then it's going to come up to this level, and we're going to call that a stop level. In this case, -1 is our stop level. Then we're going to skip over the space that the sine function occupies, and then pick up with what I'm calling a restart, in this case at 1, and then go up to positive infinity. I'm going to pause for that bell. All right. So again, negative infinity because it's pointing down, up to where it stops, where the red stops and cuts off, skip over where sine is, then restart, then up to infinity. So in this case, it would be negative infinity to -1, bracket, a U, bracket. It starts up again at 1, and then off to positive infinity. Same thing actually over here for secant. It's going to go down to negative infinity, cut off at -1, pick up again at 1, and then go off to infinity. So you're just describing the range for the red curves here. All right, I know I had said I was going to do that first example in this video, but since I'm going on 8 minutes now, I think I'm going to pause, and then I'll do the first example in the next video. So I'm going to then switch over to these examples here and walk you through graphing those. All right, be back in a flash.